Hi Rangers, in this video we're going to talk about transformations of quadratic functions. So we're going to be moving it. That's what translations means. We're just moving it up, down, left, right. So starting off with some key vocabulary, a parent function is the most basic function of a certain type. So it's the OG, it's the original graph. Okay, so while the linear parent function is y equals x or f of x equals x, the quadratic parent function is f of x equals x squared. So we're going to complete A through C to see how it changes the parent function of that quadratic function. So starting off with our table, we're going to start with f of x equals x squared. So we're going to go to our graph. We're going to type in that equation. So x squared. We're going to hit Control T to get the table. I have to do it a little differently on the iPad, and I want the values -2 to +2. So -2 is 4, -1 is 1, 0, 0, 1, 1, and 2, 4. So I'm going to fill in those values. So we had 4, 1, 0, 1, 4. Okay, and let's go ahead and graph that parent function. So I'm going to graph -2, +4, -1, +1, 0, 0, 1, +1, and 2, +4. And I'm going to connect the dots. And it makes us a nice little quadratic function. Now, for our second function, g of x equals x squared plus 2. So I'm going to start with a new graph. I have x squared plus 2. Enter. I am going to get my table, Control T, and again I want the same x value, so -2 to +2, so I have 6, 3, 2, 3, 6. So now all I'm going to do is graph that function. So I'm going to start, so I have -2, +6, which is here. I had -1, +3, 0, 2, 1, 3, and this one right here. So I'm going to graph it. So it looks like that. So notice what happened from the original graph, which is in red, to the second graph in blue. It shifted up. How much did it shift up? Well, if we look at that vertex, it went from 0, 0 to 0, 2, so it went up 2. Look at the number that we added to it. Okay? So could you take an educated guess on what's going to happen with h of x? So keep that in your mind. Let's see if it's true. So we're going to graph x squared minus 9. So I go to my, oops, that's not the graph. I'm going to go to my graph. I'm going to start with a new graph. I'm going to graph x squared minus 9. Control T to get my table. Again, -2 to +2, so I have -5, -8, -9, -8, and 5. -5. So here we go. We had, let me switch colors one more time, something that's different. So we have -5, -8, -9, -8, and -5. So I'm going to graph these values. So I have -2, -5. I have -1, -8, 0, -9, 1, -8, and 2, -5. So I have this green graph right here. So was your prediction correct? Did you think it would move down? Hopefully you did. And how much did it move down? It had to move down 9 because that's the number in the equation. So let's talk about it. And describe how the equation in the graph of g of x compares to f of x. Well, g of x, the equation had an +2, so the equation added 2, which meant the graph moved up 2. Okay, and then we're going to go on to B. Describe how the equation in the graph of h of x compared to f of x. Well, the equation subtracted 9 which caused our graph to go down 9. Now notice, I didn't say go down -9. The down part satisfies that negative. So that's why I'm not saying -9. Okay, the down is the negative. Okay, so now what we're going to do is we're going to summarize what we just discovered. So if f of x equals x squared, then f of x plus d shifts the parabola vertically. So remember, vertically is up and down. Okay, now this right here is known as function notation, so you could also see it like that, where they tell you f of x equals x squared like they did, and then maybe they say f of x plus 2, which means it would be like g of x up here, so keep that in mind. Then let's fill in the rest of the blanks. If d is greater than 0, which means it's positive, so f of x plus d, it will shift the parabola up. So remember, that was like g of x. It went up when we added. If, I'm sorry, ignore that positive comment right there. I thought it was going to say something different. Okay, sorry. So if d is greater than 0, and f of x minus d will shift the parabola down. So that was like our last example, h of x. Okay, so if you see f of x plus d, it's going up. If you see f of x minus d, it is going down. So Lorenzo translated f of x to create m of x. Use the graph to answer A and B. So here's the original function right here. We need to know, what did he do to get m of x? Well, it looks like it went down. So we need to figure out how much did it go down. So it looks like it went from 0 to -7, which means it goes down 7. So we want to write a function that represents that. Well, that is similar to h of x, but instead of subtracting 9, we're just going to subtract 7. So we have m of x equals x squared minus 7, and that's it. Okay, now we're going to compare the features. So we're going to start with f of x. So what is the vertex of f of x? That's the one I have highlighted in yellow. That would be 0, 0. The domain of all quadratic functions when they have 2 arrows is all real numbers. The range, it's opening up. My minimum point is 0, so my y values are getting greater than or equal to 0. So y is greater than or equal to 0. Axis of symmetry is x equals the x value of the vertex, which is 0. Now we're going to go to m of x. So that vertex is 0, -7. The domain is still all real numbers because it has arrows, which means it's going to keep going. But my range is going to change. Remember, we used the y value of the vertex for the range, so my y values are getting greater than or equal to -7. And the axis of symmetry is the x value of the vertex, so that is x equals 0. So now we want to see what key features are different based on this transformation. Well, the vertex is different, and the range is different. Everything else is the same. Okay, so this is vertical translations, moving the graph up and down. Now, let's go to the back. The parent function of f of x equals x squared is shown on the right. In A through B, observe how transforming the function using f of x minus c, notice how it's inside the parentheses, affects the graph. So, A, enter the function p of x minus 2 squared in your calculator. Sketch its graph on the right and describe how the equation in the graph compared to f of x. So we're going to go ahead and graph this function right here in our calculator and use the table. So I have a new document. I'm going to add a new graph, and we're going to type in x minus 2 squared. Okay, so I hit enter. I'm going to pull up the table, Control T, and then I'm going to pull up my document so we can plot them. So I'm going to use the same values that we did before, or whatever I can graph on the screen, because it doesn't look like it can graph -2, 16 on the screen. So I'm going to start with -1, positive 9. So -1, positive 9 is right here. Oops, that's not the right tool. Is right here. Okay, then I'm going to go to 0, 4. So 0, 4. Oh, right here. Miss Ryan is messing up over here. Okay, then I have 1, 1. I have 2, 0. And I have 3, 1. 4, 4. And 5, 9. So I probably graphed a little more than I needed to, which is perfectly fine. Right there. Okay, so I'm going to connect the dots. Okay, so now let's just go back to this real quick. Super zoomed in. So, how did it change? Well, it looks like it moved to the right 2. So, when we subtract 2 from the input, from the inside, it's going to move to the right 2 units. So let's say moved right 2 units. Okay, so when there's subtraction, it moves to the right. So what do you think is going to happen? We're going to make a prediction when we have a plus on the inside. Okay, so make a prediction. Think to yourself, how's that going to happen? And let's graph it and see if your prediction is correct. So I have my graph. I'm going to type in x plus 4 squared. Enter. Okay, Control T to get my table. And then I'm going to put my notes on top so oops. There we go. Let me change my pen. Again, let me change the color. Oh, I got to go back to change my color. Sorry. There we go. Okay. So now let's put this back. Whoop. So here we go. Let's see where we can graph. Doesn't look like it can graph any of those numbers, so I'm going to go in the negative direction. And look, it's getting smaller. So we're going to start with -1, positive 9. -1, positive 9. -2, positive 4. -3, positive 1. -4, 0. -5, positive 1. -6, positive 4. And -7, positive 9. Okay, I'm going to connect my dots. Ooh. I did not do a good job with that one. That's okay. Let's look at it. How did this one move? Well, if you guessed that it was going to move to the left, you guessed correctly. And it moved 4 units. Okay, so whenever there is a plus sign, it goes the opposite way. So that's what we need to keep in mind. When we're plugging in a number, if it looks like a minus, it goes in the positive direction. If it looks like a plus sign, it goes in the negative direction. So let's summarize this. If f of x equals x squared, then f of x minus c shifts the parabola horizontally, which means it's going to move left or right. Okay, so if it looks like x minus c, that is when it moves it to the right. If it looks like x plus c, then it's going to move to the left. So you have to remember that this one is opposite of what it looks like. Okay, so we want to complete the table to compare the features of f of x and p of x above. Then circle the features that a horizontal shift will change. So p of x was my graph in blue. So that's this graph right here, p of x. And f of x was the one that was given to us, the original function, f of x. Okay, so let's compare. We're going to start with f of x. F of x vertex was at 0, 0. The domain is going to be all real numbers because we graphed it and it has 2 arrows. The range, well, it's starting from 0 and it's always going up, so the y values are getting greater than or equal to 0. The axis of symmetry is the x value of the vertex, so x equals 0. Then let's go to p of x. So its vertex is 2, 0. Its domain is still all real numbers. Remember, most of the time, quadratic functions have all real numbers for the domain unless it's a real-world situation or we give you a domain restriction. The range values, they are getting greater than or equal to 0 because that's that lowest y value. And its axis of symmetry is x equals the x value of the vertex, which is 2. So what changed when we did a horizontal shift? Its vertex and its axis of symmetry. Okay, so let's look and see what the last little bit has for us. The graph of f of x equals x squared was transformed to create functions a through d. Use the functions to answer questions 4 through 6. So number 4, describe each transformation in your own words. So let's look at a. This one right here is a. So to me, a looks a lot like what we started with on the front page because it's not inside the parentheses with the x. So remember, when it's not inside, that means it's moving up or it's moving down. So since it is a minus 2.5, that means we are moving it down 2.5 units. Down 2.5 units. Okay, when I look at B, notice that it is on the inside with it. When it's on the inside, it moves left or right. And remember, it moves opposite of what it looks like. So what I mean by that is that we would think that that would be a -8, but it's opposite. It's really moving to the right 8 units. So right 8 units. Then looking at the next one. Okay, again, it's on the inside. So when it's on the inside, it's moving left or right. Oops. And again, the last one we did had a -8, and so that moved to the right. This one has a plus 2.5, which means it's going to move to the left. Remember, it's opposite. So this one is going to the left 2.5 units. And last but not least, D, we have x squared minus 8. There's no parentheses. So since there's no parentheses, it's not moving left or right. So that means it has to move up or down. And since it's a minus sign, that means it's going down 8 units. Okay, awesome job. Next, which cards have functions with the same axis of symmetry as f of x? So remember, when we did horizontal translations, meaning moving left or right, the axis of symmetries were different. But when we go to the front, when we moved it up or down, the axis of symmetries were the same. So we want something that's moving up or down to have the same axis of symmetry. So that would be card A and card D. Okay, card A and card D. because when we move it vertically up or down, the axis of symmetry did not change. Now, we want to know which one has the same range as f of x. Well, that was when it was a horizontal translation. Look at how the range is the same here. So that means it's moving left or it's moving right. So, which two move left and right? That would be B and C. And then which ones have the same vertex? Well, if we look at what we circled was different, for horizontal translations, the vertex was never the same. The same goes for vertical translations. Those vertexes weren't the same. So none of these are going to have the same vertex. Okay, last question. Haley graphed one of the functions below. Which function did Haley graph? Well, remember, our parent function starts at 0, 0, and it looks like she moved to the right. So which function moved to the right? That would be function B. So it looks like she graphed h of x. So she graphed B. Okay, so if you have any questions, please make sure you write them down and you ask your teacher.